Hello and welcome to today's lesson. Today we are looking at solving radical equations. So please make sure you either have my notes page or a place in your notebook to take some notes here. So as we get started, our objectives that the mathematicians, you all can solve equations containing radicals as well as being able to identify extraneous solutions. So let's go ahead and get started here. First of all, vocabulary. A radical equation, what is it? It is an equation that has a variable in a radicand. So we have some examples like the square root of x minus 5 equals 3. The square root of x minus 2 equals 1, things like that. So in order for us to solve those, we can solve some radical equations by squaring the sides of the equation and then also testing the solution. I know that oftentimes we skip over the testing or the checking our work step, but today it's going to be especially important and you will see why here in a little while. So let's go ahead and get started. How can we solve this first question? We first do need to isolate the radicand. In this case, that is similar to or is the same as isolating the variable. So I am going to draw my line and subtract 7 from both sides. The square root of x is equal to 16 minus 7 is 9. Now at this point I see the square root of x equals 9. When I see this, I want to remember that the opposite is what I am looking to do. So in the first step I had positive 7 or plus 7, so I subtracted. Right now I have the square root, so the opposite of that is to square both sides of my equation. On my left side with my x, my square root and my square cancel each other out, and I am left with x. 9 squared is 81. So I do want to double check that. Square root of 81 plus 7, is that equal to 16? Square root of 81 is 9. 9 plus 7 is 16, and those do match. So x equals 81 is my answer. Alright, so please go ahead and, you've got a got it here, so please go ahead and try the got it. Pause the video, do the best you can, and when you're ready to check your answer, please resume. Alright, welcome back. Here is your answer. The answer is 9. So if you are not sure how I got that, where that came from, anything like that, please pause your video and raise your hand, and I would be happy to help you. Otherwise, we are going to continue on here to problem number 2. Problem number 2. Solving with radical expressions on both sides. So as we take a look here, what is the solution of the square root of 5g minus 11 is equal to the square root of g plus 5? How can we solve this problem? Well, my radical signs, my square root symbols, are isolated. They're on their own sides. And so what I need to do is square both sides. Now once again, by squaring both sides, I am eliminating the square root symbol. So square and square root cancels each other out, and I have 5g minus 11 is equal to g plus 5. So now I need to solve it just like any other equation. Minus g, 4g minus 11 equals 5. Add 11, 4g is equal to 16. Sorry, I'm getting towards the bottom here. Divide by 4 on both sides, and g equals 4. So once again, I do want to plug that in and make sure that it works. 5 times 4 minus 11 is equal to 4 plus 5 square root. Okay, so 4 times 5 is 20. 20 minus 11 is 9. Square root of 9 is 3. On the right side, square root of 4 plus 5. 4 plus 5 is 9. And 9, whoops, sorry. Square root of 9 is 3. So I am left with 3 equals 3, which is a true math statement. Therefore, my answer of G equals 4 is the correct answer. Alright, so go ahead and take a look at the Got It. Please pause your video, give it a try, and if you have any questions, raise your hand and let me know. Alright, welcome back. So here is your answer. Your answer is 7. Once again, if you do not understand how I got 7, please pause, raise your hand, and I am happy to help. So let's move on here. We do have some vocabulary to discuss before we go over the next couple of questions here. An extraneous solution, a vocabulary word, is an apparent solution, so something that appears like a solution but does not actually satisfy the original equation. So when I solve an equation by squaring the sides, I create that new equation. The new equation may have some solutions that do not satisfy the original. So if the original equation says x equals 3 and you square both sides, your new equation is x squared equals 9, making it seem that the solutions, the apparent solutions, are 3 and negative 3. But sometimes there is an extraneous solution, or a solution that does not actually work. So let's take a look at problem number 3 here to see what this looks like. So as I look, I have my square root or my radical already isolated, so I am going to square both sides to cancel out that square root. I end up with b squared equals b plus 12. Now at this point I need to continue solving, again still trying to isolate that variable. So I'm going to subtract b and I'm going to subtract 12 so that my equation now looks like this. Now this equation should look extremely familiar to you considering we just finished a test on quadratics. This is a quadratic. We've got a b to the power of 2 or b squared there, so I can solve it in multiple ways. What I see here though is that it looks like factoring might actually be the easiest because I can find numbers that multiply to equal negative 12 but add to equal negative 1 pretty easily. So my numbers that multiply to equal negative 12 but add to equal negative 1 are negative 4 and positive 3. Once I know that, I set b minus 4 equal to 0, which means one solution is b equals 4. And then I set b plus 3 equal to 0, which makes one solution, or my second solution here, sorry, b is equal to negative 3. Okay, so here is where the important part comes in. I need to substitute those in to see if they work. So if I am first looking at the 4 squared, I added the squared. 4 equals the square root of 4 plus 12. 4 equals the square root of 16. And that is a true math statement. So 4 is a solution to this radical equation. Now I'm going to have to do some erasing of my work here, so I do apologize. I need to substitute my other value in as well. Negative 3 equals negative 3 plus 12, and the square root of that. Negative 3 plus 12 is 9. However, the square root of 3 is positive 3, not negative 3. So because these are not equal, negative 3 is not a solution. Okay? So what that means is negative 3 is an extraneous solution. It is a solution, an apparent solution to the problem, but does not actually satisfy the original equation. Now, as we continue on here, something that I do want to mention here as I move on to the got it question, as we were looking at the solution and how we solved this, I want you to notice that we did factor in this to solve that. I want to point out that that does not only apply for extraneous solutions, that sometimes you will have to use factoring to get your answers, or to get your answer. And so just make sure you are aware that that is not only for extraneous solution problems, but that sometimes you might need to apply that knowledge as a way to solve. Okay, so go ahead and pause the video. Here's the got it. And when you are ready to check, please resume your video. Alright, so welcome back. At this point you should have this solved, and your answer to this particular got it number 3 is that your answer is negative 2. So if you are having questions, please again make sure you pause and raise your hand. And I can help you out. Alright, so taking a look here at this problem. So if we take this problem and we start it just like we started at the beginning, isolating the radical, subtract 8, sorry that is sloppy, subtract 8, square root of 3y, and 2 minus 8 is negative 6. At this point, I can square both sides and get 3y equals 36. Divide by 3 and y equals 12. So what happens then when I plug that in? 3 times 12 plus 8 equals 2. 3 times 12 is 36. 6 plus 8 does not in fact equal 2. So what happened here? 12 does not satisfy the original equation. So the apparent solution is 12, but it's extraneous. So what is my solution? Well, I want to go back to this step right here, and I'm going to rewrite it up here at the top. We had the square root of 3y is equal to negative 6. And I want you to just take a look at that here for just a second. The square root of something is equal to negative 6 is what this says. Can the square root of anything be equal to a negative number? I've repeated that multiple times as we have been looking at quadratics recently, and the square root of something is not going to equal a negative number. That is when you will get into imaginary numbers, and we are not going there right now. So, because of this, a square root equal to a negative number, I can right then and there tell that this question is actually a no solution answer. Now, if you don't see that at that point, that is completely okay. You can get down to this point and check your answer and notice that this does not work, and know that the answer is no solution because the one solution that you found is extraneous. So please go ahead and try the got it once again. Please pause it, do your best, and then when you're ready to check your answer, resume your video. Alright, welcome back. Hopefully you got that done. And your answer for this one is also no solution. Once again, pause and raise your hand if you need some help. So, one last thing here. How could you determine that the equation square root of x equals negative 5 does not have a solution without going through all the steps? Please jot some thoughts down on your paper. At this point, some things that should be running through your mind, or the main thing that should be running through your mind, is that the square root of any number cannot be having a negative answer. So no matter what, square root of x, whether it's a whole number, a decimal, is perfect square, not a perfect square, you are not going to end up with a negative answer. So at this time, you are done with this lesson. Please show me your notes page to get the homework assignment.